Ever wondered how to build scalable and modern microservices? You're in the right place. Welcome to Microservices in the Cloud with Jay, where we dive into the exciting world of microservices, cloud computing, and modern IT architecture. Together, we'll cover practical topics like communication between services using REST API with Feign Client, event-driven systems powered by AWS Kafka, and messaging patterns with AWS SQS and SNS. We'll also explore the foundations of data storage and efficient search strategies using tools like MongoDB, AWS DynamoDB, OpenSearch, and AWS S3. These technologies drive modern cloud-native applications, and I'll guide you through real-world scenarios to make them accessible and actionable. Throughout our journey, we'll uncover the strategies and technologies powering some of the world's most successful tech platforms. And to make it all practical, we'll implement these concepts using Spring Boot and Spring Cloud in Java, ensuring a modern, scalable, and enterprise-ready approach. Make sure to subscribe so you don't miss any episodes. Join me as we explore the cutting edge of technology. Let's get started. In this video series, we will build a complete microservices system step by step. We'll start by preparing the context in which we'll be working, and then move on to building the back-end part of the system for order management, complete with key functionalities. First, we'll focus on creating the Orders API Microservice, responsible for managing orders. In subsequent steps, we'll develop the Payments API Microservice for handling payments and the Inventory API for managing inventory states. Of course, we'll also include the Users API, where we'll discuss authentication and authorization processes for users. During this series, we'll use NoSQL databases, including MongoDB, which are currently highly popular in the world of microservices. They are flexible, scalable, and well-suited for modern distributed systems. Additionally, since so much has already been written about relational databases, we'll focus on something more modern and practical. Moreover, throughout this series, you'll learn how to leverage AWS as a cloud services ecosystem. We'll be working in a Java environment using Spring Boot and Spring Cloud. The project will be built using Maven, although you can also use Gradle if you prefer. Just remember that the code available on GitHub will include Maven XML files rather than Gradle configurations. Now that you know what to expect from the first videos, I'd like to inform you about the knowledge required to fully benefit from the materials in my videos. You'll definitely need to have programming skills in Java and be familiar with tools and frameworks like Maven and Spring Boot. It's also important to have a general understanding of what microservices are and why they are used, although we'll be covering many of these topics in detail during the upcoming lessons. That's all for the introduction. Now, let's start working with the code. Get your IntelliJ ready, and let's dive in. We begin our work by creating the skeleton of the first microservice. This will be a service responsible for storing orders. Of course, this service will be part of a larger ecosystem, so we should definitely consider communication with other services during its development. The first service we will tackle is the Payments API. Initially, we will prepare a synchronous configuration using REST API. The Orders service will be tasked with sending requests to the Payments API service. We create the Orders API using the New Project option, where we set the project name and choose the project's build system. As you can see, I have already created the Orders API project and used Maven as the build tool. With the project skeleton in place, I will immediately add the main package path and also include the first dependencies. The first one, Spring Boot Starter Web, will allow me to use Spring MVC, enabling the development of web applications. This includes defining controllers for handling HTTP requests. The second dependency, Lombok, will make it easier to create classes by eliminating the need to write boilerplate code, such as getter and setter methods or constructors. This will make the code more readable and less prone to errors. Now I will build the project using Maven so that all dependencies are downloaded and installed in my local M2 repository. Since I have a successful build, I can proceed with writing the microservice code. I am creating two packages, API and Service. The API package will contain controllers and definitions of REST API endpoints. The Service package will hold the business logic of the application. In the API package, I am creating an additional subpackage called Model, which will store classes and records, representing the data used in API communication. I am preparing a record payload for the endpoint. The first parameter, order ID, is a unique identifier for an order. The second parameter, amount, is a big decimal, which allows precise operations on decimal numbers, avoiding rounding errors, important when dealing with monetary values. I am adding an infrastructure package where I will soon create my client for calling the payments microservice. In this package, I am adding a subpackage called Client. Here, I am creating the skeleton of an interface that I will use for communication with the payments microservice. Next, I will create a model package within infrastructure where I will define a record for the payload that will be sent to the payments service. At this point, I would like to preliminarily set up communication with the future payments API service. For now, this service does not need to exist. I will implement the communication using Feign Client, which I will discuss in more detail shortly. To add Feign Client to my project, I first need to include cloud libraries, which enable integration with various components of distributed systems. These are toolkits provided by Spring Cloud that simplify the implementation of solutions, such as inter-service communication, configuration management, or service handling in cloud environments. To achieve this, I add a dependency management section in the Palm XML file, which allows me to centrally manage the versions of dependencies related to Spring Cloud. I set the version to 2020.4.0.0 because, according to the official documentation, Spring Cloud Release Train 2020.4.0 supports Spring Boot versions 3.4x. Introducing this section allows for automatic inheritance of Spring Cloud library versions in the project. This means that when I add, for example, Spring Cloud Starter Open Feign in the next steps, I don't need to manually specify its version. It will automatically align with the version defined by Spring Cloud dependencies. Adding this configuration is a crucial step when working with microservices, as it ensures consistency and compatibility between various Spring Cloud components in the project. Now, I will add the mentioned dependency for Open Feign. Since I have included everything needed in the Palm XML file, I can now download and install the dependencies into my Maven repository. Finally, I will refresh the project. So that IntelliJ IDEA recognizes the latest libraries. By expanding external libraries, I can verify if the libraries have been added. As you can see, both Spring Cloud and Open Feign appear in the list. Great! Let's tidy up by closing anything unnecessary to keep things organized and continue working. I will now create the main class for my service. If you already have a predefined main class, you can simply rename it. My suggestion is to name it Order Service Application. I am adding the Enable Feign Client's annotation because it enables Feign Client support in the application. Spring knows to scan the project for classes marked as Feign Clients and configure them automatically. Note that the Enable Feign Client's annotation is available because we previously added the Open Feign library to the project. At this point, you might be wondering why I chose Feign Client as the tool for communication between services. Well, Feign Client is designed to simplify and optimize communication management. Let's take a closer look at what makes it such a popular choice in microservices. Feign Client allows for declarative API definitions. Instead of writing complex code to handle HTTP requests, you simply create an interface with appropriate annotations like get mapping or post mapping. This makes the code more readable and easier to maintain. Feign Client integrates seamlessly with the Spring Cloud ecosystem. You can quickly set up communication between microservices by leveraging Spring's built-in mechanisms. For example, you can use configuration properties to define service names and URLs, making it simple and effective. Feign Client eliminates the need for repetitive HTTP code, as seen with tools like REST template. Instead of manually configuring requests and handling responses, Feign generates all the necessary code for you. This saves time and reduces the chance of errors. Feign Client provides mechanisms like retry and fallback, which enhance the resilience of your application. If a request fails, you can define an alternative path for handling errors, as shown in the inventory client fallback example. With its modular approach, Feign Client adheres to solid principles, making the code easier to understand and maintain. Clearly defined interfaces improve clarity, which is essential in complex systems. Feign Client is easy to mock in both unit and integration tests. You can simulate HTTP interactions, allowing you to effectively test your application logic without actually communicating with external microservices. This significantly speeds up the testing process. As you can see, Feign Client offers a wide range of benefits that make it an excellent choice for managing communication between microservices. Its simplicity, efficiency, and seamless integration with Spring Cloud streamline development and improve maintainability. By leveraging these features, you can focus more on business logic and less on boilerplate code, ensuring a more robust and scalable microservices architecture. In the next video, we'll create the skeleton of the Payments API service and use Feign Client to send a request from the Orders API service to the newly created Payments API. Make sure to check it out and continue building along.